The beauty of geometry often lies in its uncanny ability to extract absolute, undeniable order from a seemingly chaotic scramble of numbers. When you first map out this specific intersection of lines, the initial data feels entirely uncoordinated, a scatter of clumsy, asymmetrical angles measuring 49, 70, 52, and 99 degrees. There is no rhythm to those numbers, no obvious harmony. It looks like a collision, an accident of drafting. Yet, the moment you step back and look at the canvas as a fluid whole, a hidden architecture begins to unfold. You begin the unraveling process not by looking at the mess, but by filling in the blanks. By measuring the empty spaces, you smoothly calculate the hidden apex of the primary triangle. Next, you pivot and unmask the remaining sharp, overlooked corner of the traversing triangle. Suddenly, the perspective shifts. You realize these two independent steps have quietly worked in tandem to trap a tiny, central subtriangle right where their paths cross. This is where the geometric trap snaps shut with absolute elegance. Those two newly discovered angles, born from completely separate shapes, nestle perfectly inside that tiny central pocket. When they meet, they instantly combine to claim exactly half of a triangle's total degree budget. They leave the third, defining angle of that central space with absolutely no choice but to absorb the rest. And because our ultimate target, angle PTC, directly mirrors this central pivot as a vertical opposite, the structural illusion fades away entirely. It reveals that this messy collision of random, awkward lines has organically, inevitably locked itself into a framework of flawless, perpendicular precision, delivering a final measure for angle PTC of exactly 90 degrees.